The goals of this video are to write a conditional, converse, inverse, and contrapositive of a statement and complete a statement of logic using the chain rule. So geometry is built on a deductive structure. That means it's a system of thoughts in which conclusions are justified by means of previously assumed or proved statements. So a deductive structure is composed of 4 elements. The first is undefined terms. These are words that we have an understanding of. The 3 most important undefined terms in geometry are a point, a line, and a plane. Postulates are unproven assumptions. Definitions state the meaning of a term or an idea, and theorems are mathematical statements that can be proven. So later on when we get into proofs, we can actually prove some statements, which are then theorems. One important fact about definitions is that they are reversible. So definitions work from one direction to the other, while postulates and theorems are not reversible. So recall from the other day a midpoint. So the definition of a midpoint is if a point is a midpoint of a segment, then it divides a segment into 2 congruent parts. If we were to reverse it and say if a point divides a segment into 2 congruent parts, then it's a midpoint, that works both ways because it's just telling us what a midpoint does, what the role of a midpoint is. So some definitions, such as the one up here as an example, are written as conditional statements. Conditional statements are written in the form if P then Q. The if part of the statement is called the hypothesis, and the then part is called the conclusion. So when we are looking for our hypothesis and conclusion, we don't include the words if and then. They are triggers to help us find. So the hypothesis is represented by P, and the conclusion is represented by Q. So we could have if then, if P then Q. We can also write it as P arrow Q, or we can say P implies Q. These are all different ways to mean the same thing. So we have declarative form and we have conditional form. Declarative form just tells you how it is. Right angles are congruent. Conditional statements, though, have our hypothesis and our conclusion. So if 2 angles are right angles, then they are congruent. The hypothesis is the 2 angles are right angles. The conclusion is they are congruent. So let's take the following given declarative statement and rewrite it as a conditional statement. So the declarative, elementary students will have recess outside when it is sunny and warm. If we want to change this into an if then, we need to separate this into 2 parts. So one main idea is that they're having recess outside, and one main idea is that it's sunny and warm. So we could write if elementary students have recess outside, then it is sunny and warm. So another type of statement is a converse. A converse is created when P and Q are flipped. So we now have Q to P. Because the converse reverses the statement, it's not always true, as discussed in the idea above. So if elementary students have recess outside, it is warm and sunny. But if we reverse it, we said if it is sunny and warm, the elementary students have recess outside. That's not necessarily true because they might still be in class, or there might not be school, or they might be on a field trip. There's could be a lot of reasons of why they're not actually outside having recess. So the flip doesn't necessarily mean it's true. There are 2 other variations of conditional statements: the inverse and the contrapositive. Both involve the negation. For negation, we are going to use the symbol of that tilde to represent the negation of a statement. The negation of a statement of P is not P, or we have tilde P. Another thing to notice though is that a negation of something that's already negative, so if it is not snowing, means that it is snowing. So negation here really means the opposite. We're not going to say not something. We're not going to say it is not snowing, right? In English, those two words of the not cancel out, so we just say it is snowing. So here's an example of each type of statement. A conditional statement. If you live in Chicago, then you live in then you live in Illinois. That is P to Q. The converse switches the order. So if you live in Illinois, then you live in Chicago. This statement is false because not everybody in Illinois is a resident of Chicago, right? You could live in Gurnee. If you do not live in Chicago, then you do not live in Illinois. This is also false because, again, if I don't live in Chicago and I live in Gurnee, that's still part of Illinois, so I'm still living in the state of Illinois. Whereas the contrapositive, if you do not live in Illinois, then you do not live in Chicago, right? If you're not in Illinois, you can't be a resident of a city of Illinois, so that would be a true statement. So, an important theorem about these statements is if the conditional statement is true, then the contrapositive is also true. This is very important for later on in our lesson. So let's just practice right now writing the conditional, converse, inverse, and contrapositive, then determine if the statement is true or false. So the declarative statement here is if an angle is 30 degrees is an acute angle. So if we are going to write an if-then statement for our P to Q, we could write if an angle is 30 degrees, then it is an acute angle. That's true because acute angles fall between 0 and 90, so if it's 30 degrees, then it has to be true. The converse switches the order, so we are going Q to P. So when I switch the order of my conditional statement, if an angle is acute, then it measures 30 degrees. That is false because not every acute angle is going to have 30 degrees. Some of them might be 31 or 62 or 89, right? There's lots of different angle measurements that an acute could be. An inverse operation keeps the same order as the conditional, but it takes the opposite. So because these are both positive statements, we're going to negate them by adding a not in. So if an angle is not 30 degrees, then it is not an acute angle. Okay, so notice that we negated both of them by putting not in. This statement is also false because just because our angle is not 30 degrees doesn't mean it's not acute, because we still have lots of other angle measurements to make it acute. Our last statement then is a contrapositive, so we're going to take the negation and we are going to switch the order. So if an angle is not acute, then it does not measure 30 degrees. This is true because if I don't have an acute angle, there's no way it can be 30 degrees because 30-degree angles are acute angles. Now, we're also going to write a conditional, a converse, an inverse, and a contrapositive using letters. So the conditional statement here is B to D. The converse switches the order, so we would have D to B. The inverse keeps the order, but it makes it a negation, so we would have not B to not D. And the contrapositive is going to switch the order and take a negation. So it'd be not D to not B. Our last type of statement then is a biconditional. A biconditional statement occurs when the conditional and the converse are true. So if a biconditional can be written as P if and only if Q, or P arrowing both ways because it works front and back to Q. For example, we might have an angle is right if and only if it measures 90 degrees. So remember this only, what happens here in a biconditional is we put if and only if in, and we take out if and then. So as a quick summary, your conditional statement goes from P to Q, your converse goes Q to P, your inverse is not P to not Q, and your contrapositive is not Q to not P. The rest of the lesson, we are going to talk about the chain of reasoning. So sometimes in mathematics, we are able to use logic to draw more conclusions than what you have originally assumed. We do this by forming a chain of conditional statements. This method is called the chain rule. You use the chain rule in everyday life. Here's an example. Mike is taller than Lisa. Lisa is taller than Susie. Therefore, we can conclude, okay, well, if Mike is taller than Lisa, and Lisa's taller than Susie, that means Mike is taller than Susie. So we're taking out that middle person, Lisa, so that we can connect Mike and Susie by their height. When we are using the chain rule, it is important to remember that the contrapositive of the conditional is always true. So if we have x to y, we also have not y to not x is equally true. Or if we had not C to D, when we switch it, we would have not D to C. So let's see if we can make conclusions. So in A, we have three statements: A to not B, M to not X, and not A to X. So first thing we want to do is we want to look at what letter starts one of the statements and doesn't repeat anywhere else. So that letter is M. So I'm going to write this as M to not X because I want to reorder my statements. Whatever I end with, I have to start with in the next statement. So I have to start with a not X, which I don't have right now. I just have X. So I'm going to use the contrapositive to flip this statement around. So it becomes not X to not A. Oh, to A, sorry. Then we have this last statement that goes A to not B. Now, there's some letters that repeat. So just like Lisa being taller, we can cross those letters out and we are left with M to not B. Or if we wanted to switch the order, our contrapositive, we would B to not M. In letter B, this is just another way they're not arranged correctly still. So we want to look at what's a letter that starts by itself. So J sticks out to me. So I'm going to do J to K, which means my next statement has to start with K. So we have K to B. Our next statement has to start with B. So B to not R. Our last statement has to start with not R. Right now I have R at the end. So I can do the contrapositive to switch the order. So it becomes not R to C. And we can cross out what repeats. So we have J to C. Or we could do the contrapositive, and if we started with not C, we would have had not C to not J. Another chain rule is by words. So in C, we have, if it is Tuesday night, you will have time to cook dinner. If you run to the grocery store, you will buy noodles. If you have time to cook dinner, then you need to run to the grocery store. If you buy noodles, then you will cook pasta for dinner. So we can cross out things that repeat. You have time to cook dinner. You go to the grocery store. You buy noodles. So we cut out all of that middle fluff in our story so that we can just get to the main point of it. That's what chain rule helps you do. So our main point then is if it is Tuesday, then you will cook pasta for dinner. So we have two more laws here. We have law of detachment and law of syllogism. So in law of detachment, if P to Q is true, then we can separate them in the P statement is true and the Q statement is true. So use law of detachment to make a conclusion. If you are late to class, you will get detention. Jake was late to class. So notice this late to class happened both times. The hypothesis was repeated. So because Jake was late to class, we can make a conclusion that Jake got detention. In B, if you like country music, then you like to line dance. Nick likes to line dance. The problem here is that likes to line dance is the conclusion of the statement. So if we already have a conclusion, we can't make another conclusion. So this would just be a no conclusion. We don't know why Nick likes to line dance. Maybe he likes country music, but maybe it was a family tradition, or maybe that's where he met his girlfriend. We don't know what his motive is to liking line dancing. Our second law is law of syllogism. So in law of syllogism, if P to Q and Q to R are true, then P to R is true. So we're cutting out that middle repeat. So if you can read music, you can play the guitar. If you can play the guitar, you can keep a beat. We can cross out this play the guitar because it repeats. So our conclusion then is if you can read music, then you can keep a beat. In part B, if George goes to the zoos, he will see monkeys. If George touches a stingray, he will want to become a marine biologist. And while we're happy for George, these two statements don't really have anything that go along with each other, so we can't use law of syllogism because we can't cross anything out. Monkeys and stingrays don't go together logically, so this is a no conclusion. Our last quick part then is Venn diagrams. So Venn diagrams can be used as a visual of a conditional statement. When you have a Venn diagram, your smaller circle is going to be the hypothesis, and the larger circle is going to be the conclusion. So if you are in honors geometry, then you are in math class. So honors geometry is our hypothesis, and in math class is our conclusion. So we're going to have for a Venn diagram a bigger circle with a smaller circle contained in it. So we have honors geometry and we have math class. The reason that honors geometry is small is because there's all this room for extra math classes, right? Algebra, pre-calc, calculus, statistics. There's lots of different math classes that would also satisfy this conclusion. That's why there's extra space for other classes.